Gamma rays are the highest energy form of light.
There's the light we see with our eyes, but there are lots of other types of light. Gamma rays are the most energetic form of light, the most powerful.
Gamma rays are the part of what we call the electromagnetic spectrum, which starts in radio at very long wavelengths, goes through optical, then through X-rays, and then gamma rays are the very highest energy form of that type of radiation.
The reason that it's important to look at the high energy gamma rays is that many objects, the most violent and some of the most interesting objects in the universe, emit most of their light in this high energy gamma ray part.
And the only thing that can generate gamma rays are incredibly violent events, incredibly energetic events. And we're talking stars exploding and neutron stars with really strong magnetic fields and really exotic and strange objects like that.
It's like a Christmas tree. It's shining and it's flaring and there are eruptions every day.
Gamma ray bursts being an example, something that for a brief instant of time outshines the entire rest of the universe.
These are the biggest explosions in the universe.
Gamma rays look like a spiral with a beam of light piercing through the center. Gamma rays have a frequency of greater than 30 hexillion hertz, a wavelength of less than 1/10,000,000th of a centimeter, energy of greater than 100,000 electron volts, and a wave speed of 300,000 kilometers per second.
Most gamma rays are absorbed as they go through Earth's atmosphere. According to the National Aeronautics and Space Administration, or NASA, the Earth's atmosphere is as thick to gamma rays as a 12-foot plate of aluminum. However, few rays strike the material in our Earth's atmosphere and produce secondary particles, which then can make it through Earth's atmosphere. Most of the cosmic rays that reach Earth's surface are produced when the original gamma ray hits the Earth's atmosphere. However, these are secondary cosmic rays. The primary cosmic rays are stopped and break into smaller particles at the Earth's atmosphere, or they are deflected by the Earth's magnetic field. Thankfully for us, very few gamma rays make it through the Earth's atmosphere.
The practical uses of gamma rays include radiotherapy, where gamma rays are sent through the body to kill cancer cells, as well as to sterilize equipment and food.
Gamma rays are a terrible idea to bring with us on our mission to Mars. First, they could seriously injure anyone that we brought up to Mars in the first place. If they are exposed to too much radiation, they could die quickly. Also, it could cause long-term illnesses like cancer. Astronauts are not very useful dead. Another thing to consider is that the ultimate goal of going to Mars is to set up a colony. The colonists will not do much good if they are ridden with cancer and genetic mutations. However, sterilizing instruments as well as food and other things is very important as well. But when you weigh the pros, clean things, versus the cons, people dying and getting cancer, it is in our best interest not to bring gamma rays on our mission to Mars. In the event that there is one instrument essential to our survival that needs to be kept clean at all times, a very small amount of gamma rays should be provided. They should be kept isolated and separate from everything else to prevent injury.
Other interesting characteristics of gamma rays include that per burst, gamma rays contain 1,000 times more energy than will ever be made by the sun until it burns out. Also, gamma rays are so far away that light reflecting on Earth today from gamma rays has traveled for more than 340,000 years.